In section 2.3, we'll be talking about basic differentiation rules. So first, let's talk about a little bit of notation. So first of all, if I see something like dy dx, that is a noun. So that just means the derivative of y with respect to x. It's a lot like saying just f prime of x or y prime. But if I see just a d dx, that's a verb. So it's actually telling you to do something, and that something is take the derivative with respect to x. These are both forms of Leibniz notation. You don't necessarily need to know that, but I might reference it from time to time. So Leibniz was one of the creators of calculus, and so Newton is the one that came up with the prime notation. This is Leibniz notation. So let's talk about the derivative shortcuts. So first of all, the constant rule, and that is that the derivative of a constant is 0. So notice this d dx, I'm taking the derivative of the constant, that's 0. And the reason why is because if you think about a constant graph, like y equals c, it would be a horizontal line. And so when I have a horizontal line, the slope is 0. That means our derivative is 0. Also, if I have a line like y equals 1, or sorry, y equals x, that slope is 1, right? So if I just have a line y equals x, that slope is 1. But let's actually think about what if I have a function that's x to the power of n. So we talked about this in class today. So if I have a function that's x to the power of n, then essentially what I'm going to do is take the n, my power, I'm going to bring it down in front. It's now going to become my coefficient, and then I reduce my power by 1. Okay, so this only works when I have a variable x and a constant n. So let's try this out. So for a, we have f of x, which is x to the 5th. It's in that exponential form that we talked about for the power rule. So I can just go ahead and find f prime of x. I'm going to take the 5, going to become my coefficient, x, and then my power that was 5, I reduce it by 1, and so my answer is 5x to the 4th. In part b, I have g of x equals the 4th root of x cubed. That's not written in the exponential form yet, so we want to rewrite it as x to the 3 over 4. Once it's in that form of x to the n, then we can go ahead and find the derivative. So g prime of x is 3 over 4, x to the negative 1 over 4. Subtract 1 from the exponent. Now you might want to rewrite that. A negative exponent just means it's in the denominator. I'm going to rewrite that as 3 over 4. And then the 1/4 exponent means 4th root of x. Now either one of those would be okay on a free response question, but a lot of times you'll see multiple choice answers like the one in the box. For part C, we have y equals 1 over x cubed. So even though I see x to the 3rd power here, this isn't actually an exponential form yet that we want. I have to rewrite it with a negative exponent. So 1 over x cubed is x to the negative 3rd. And so the derivative of y, I'm going to write as dy dx. It's okay if you call it y prime, either one is okay. That derivative would be negative 3x to the negative 4th. If I rewrite that, that's just negative 3 over x to the 4th. So we can continue on and actually multiply a function by a constant, and if that's the case, then I can just move the constant out in front and just take the derivative and multiply those together. So for example, if I have y equals 2x to the 7th, then when I take my derivative, it's just going to be 2 times the derivative of x to the 7th. So I kind of ignore the 2 for right now, I carry it along. Derivative of x to the 7th is 7x to the 6th, and then I can rewrite this as 14x to the 6th. In part B, we have 3 over x squared. So again, you want to rewrite this first if it's not in the x to the n format. So 3x to the negative 2nd. So my derivative will be 3 times the derivative of x to the negative 2nd, which is negative 2x to the negative 3rd. Make sure when you're subtracting here, you're subtracting 1, so it goes down to negative 3. It's not increasing, so be careful with those negative exponents. That's going to give me negative 6 over x cubed. In part C, we have the 6th root of x to the 5th over 8. When you see a constant in the denominator, it's usually easiest if you rewrite that as a fraction coefficient, so 1 over 8 instead of divided by 8, times, then this will be x to the 5 over 6. I'm going to go ahead and take my derivative, so 1 over 8 times 5 over 6, x to the negative 1 over 6. Simplify that, I'd have 5 over 48 times the 6th root of x. All right, for example 3, I want you to try these on your own first. Pay attention to where there are some parentheses. So try them on your own, and then come back and see if you have the right answers. So in A, it might help you if you rewrite this as 3/8 times x to the 4th. Just think of that as a constant times your variable there. So my derivative is 3 over 8 times 4x cubed, which simplifies to 3 over 2 x cubed. For part B, when you have parentheses like that, you need to distribute the 4. So I'm going to have to take 3 to the 4th and x to the 4th. So this is 81 x to the 4th over 8. So my derivative is 81 over 8. I'm just going to take that coefficient times 4x cubed, because that was x to the 4th. I know it looks like a 9 for 4, I promise. And when I simplify this, I get 81 over 2 x to the 3rd. For part C, we know the x squared is in the denominator. You need to make sure if it's in the denominator, you rewrite it with a negative exponent. So we have 9 over 7 x to the negative 2nd. My derivative then is negative 18 over 7 times x to the negative 3rd. And when I rewrite that, I get negative 18 over 7x cubed. Last one, we have 9 over the quantity 7x squared. So again, make sure you square both the 7 and the x. I'm actually going to rewrite that. I don't want to keep the x squared in the denominator. I want to rewrite it as x to the negative 2nd. So you could do that in 2 separate steps if you want. All right, so now when I take my derivative, I have 9 over 49, that part comes along, times negative 2x to the negative 3rd. Okay, so I'm subtracting 1. When I simplify that, I get negative 18 over 49x to the 3rd. So just like we did with limits, we have sum and difference rules for derivatives. And so if I am adding or subtracting two functions, I can actually just take their derivatives separately and add or subtract them. So in part A, I have x cubed minus 4x plus 5. So when I do that derivative, I just take the derivative piece by piece. The derivative of x cubed is 3x squared. The derivative of minus 4x is just minus 4. So whenever you see a constant times x, the derivative is just that constant coefficient, because it's that linear piece. And then the derivative of 5 is just 0, since it's a constant. So our answer is just 3x squared minus 4. In part B, we have g of x, which is negative x to the 4th over 2 plus 3x cubed minus 2x. So when I take this derivative, I have 4x cubed over 2, so that gives me negative 2x cubed plus 9x squared. So 3 times 3 is 9, reduced by 1. The derivative of minus 2x is just minus 2. Okay, so just take the derivative piece by piece. So those rules we just used for sums and differences do not work for products and quotients. And later on we'll learn special rules for those. But what's important is that you cannot take the derivative just of the top over the bottom when I have a quotient like this. And so we might need to rewrite it so that it is in the form of a sum and difference of powers of x. So for example here, I need to reduce this. So I have x cubed minus 4x plus 5 all over x. You might think of that, the x in the denominator is really x to the negative first times x cubed minus 4x plus 5. So that is really just, if I distribute that through, x squared minus 4 plus 5x to the negative first. Okay, so that was just distributing each of those terms. Now I haven't actually taken the derivative yet. That's just my simplified form of f of x. Now that this is in the form of a sum and difference of powers of x, I can go ahead and take my derivative. So the derivative of x squared is 2x. The derivative of minus 4 is 0. Remember, derivatives of constants are 0. The derivative of 5x to the negative first would be negative 5x to the negative second. Subtract 1 on the exponent there. And then if you want to rewrite, this would be 2x minus 5 over x squared. In part B, we have a product of two sets of terms, and so what I will want to do in that case is expand. So essentially I'm just foiling here. So expand it first. I have x cubed minus 3x squared plus x minus 3. Once I've expanded, I'm now in the form to take the derivative. So pay attention here that you're restating, like I'm calling this next part when I take the derivative g prime. This other part is equal to g of x. So when you're taking the derivative, you need to give it a new name. So the derivative of x cubed is 3x squared. The derivative of minus 3x squared is minus 6x. So the 3 times 2, reduce the power by 1. The derivative of x is plus 1. A similar idea in part C, we have x minus 3 cubed. And so you want to use the binomial theorem to expand that. So remember that if you have something like a plus b cubed, that's a cubed plus 3a squared b plus 3ab squared plus b cubed. So in this case, our a is x and our b is negative 3. So when I expand that y, I will get x cubed minus 9x squared plus 27x minus 27. And so then I can take the derivative of that piece by piece. The derivative of x cubed is 3x squared. The derivative of minus 9x squared is minus 18x. The derivative of 27x is just 27. And the derivative of minus 27 is 0. So that is our answer. For part D, g of x, again we have that quotient, so we want to rewrite the variable in the denominator as x to the negative 1/2. So radical in the denominator is x to the negative 1/2. And then I need to distribute that through before I can take the derivative. So x to the negative 1/2 times 2x squared is going to give me 2x to the 3/2. So it's 2 minus 1/2 there. And then x to the negative 1/2 times negative 3x will be minus 3x to the positive 1/2. So I have 1 minus 1/2. That is still just my g of x. I still need to find the derivative. So I'm going to say g prime of x, my derivative, is equal to 2 times 3/2 x to the negative, or sorry, to the positive 1/2. And then minus 3 times 1/2 x to the minus 1/2. So to simplify that, these 2's cancel out, so I have 3 square root of x minus 3 over 2 square root of x. You can leave it like that if you want, but sometimes you might be asked to get a common denominator. In this case, I would multiply the 3 radical x by 2 radical x over 2 radical x, just the denominator of the second part. When I multiply those together, I would get 6x. So the 3 times 2 is 6, radical x times radical x is x, minus 3 all over 2 radical x. Again, on a free response, you don't have to do that, but on a multiple choice, your answer might look like that. So let's revisit tangent lines now that we know the power rule. So this will make finding tangent lines a lot easier than when we had to do derivatives the long way. So in part A, it tells us to write the equation of the tangent line at this given point. So remember, for a tangent line, we need a point. That's given to me in this case. And I also need a slope. So for my slope, that's the derivative. Slope of the tangent line is derivative. So f prime of x, the derivative of f is 1 minus 4x. Now what's important for you to realize is that is not my slope yet. That's the formula to find my slope at a given x. So now I actually still, to find my particular slope, I'm going to evaluate it at the x value from my point, which was 1. So 1 minus 4 times 1 gives me negative 3. So this is my slope, m. Now I can write my equation, y minus negative 1, so y plus 1, equals my slope from here, negative 3, times x minus my x value, 1. Okay, so make sure when you're writing tangent lines you find the particular slope, the specific one at that point, and it's not just that whole derivative equation. Okay, same idea for b, we just have a different function. It doesn't actually give us the point this time though, it just gives us the x coordinate. So if the point isn't given, you need to find it first. So we know x equals 1, so we need to find f of 1. So it's 2 radical 1, which is 2. So we have the point 1 comma 2. To find the slope, I need to find the derivative. So remember, 2 squared of x is really 2x to the 1/2. So when I find my derivative, it's 2 times 1/2 x to the negative 1/2. That simplifies to be just 1 over square root of x. And so that means I'm going to find f prime still at 1, my x value. So 1 over square root of 1 is just 1. Now I can write my equation, y minus my y value from this point, 2, equals my slope, which was 1, times x minus my x value, which was 1. And it's okay to leave this in point slope form unless on a multiple choice problem it asks you specifically, or it only has options for like slope intercept, something like that. In example 6, we want to find the points where a graph of y has a horizontal tangent line. So whenever I see horizontal tangent line, I automatically need to think about that my derivative is equal to 0. So in this case, my function y, so my derivative is equal to 0. Okay, so derivative equal to 0. That's what I'm trying to solve. So let's find my derivative, dy dx. The derivative of x squared plus 4x minus 1 is 2x plus 4. And now I'm going to set that equal to 0 to figure out where the slope was 0. So 2x equals negative 4, and x equals negative 2. Now one other key point here is that this asks at what point does the graph of y have a horizontal tangent. When it says points like that, it's asking for an x coordinate and a y coordinate. I have my x coordinate negative 2, but now I need to find my y coordinate. So y of negative 2, I'm just going to evaluate it on that equation. So I have 4 minus 8 minus 1, which is negative 5. And so my point is negative 2, negative 5. So I have to make sure that my answer includes both of those. And lastly, number 7, we're given a function f of x, and it asks us to determine all coordinates of all coordinate points, so again the xy, on the graph of f such that the line tangent has a slope of negative 3. Again, when I see that slope of negative 3, automatically you think derivative is equal to negative 3. So I need to find my derivative first because I'm only given f of x. And then I'll set it equal to negative 3 and I'll solve. So f prime of x is equal to 3x squared minus 18x plus 21. Then I'm going to set that equal to negative 3. Now before you get excited and try to factor that left side, remember that in order to solve an equation like this, we actually want the right side to be 0. So we're going to add 3 first to make sure we have our quadratic set equal to 0 first. And now I can solve. So the first thing you want to do is divide this by 3. I could just factor out the 3 in front, but that's never actually going to give me an answer of 0, so I don't need to keep it there. So when I factor x squared minus 6x plus 8, that factors into x minus 4 times x minus 2. And so my solutions are x equals 4 and 2. Now remember though that it did ask me for coordinate points, and so I need to find my y values. So I'm going to need to find f of 4 and f of 2. So I'm just plugging those back into this original equation, f of x. You can use your calculator to help you here. F of 4 is negative 16, and f of 2 is negative 6. So my points for my answer are 4, negative 16, and 2, negative 6.